We're on page 8 of our notes after filling out the torque notes and after doing the example. What's Newton's second law? To remember, just recall the second most important person in your life. Your mom. Second most important because the first most important person is your physics teacher. Just kidding. So the second law says the net force is equal to the mass times the acceleration of the object. Let's apply this to angular motion. What's the analog to force? Well, force is sort of a linear motion, linear acceleration. So what relates to angular acceleration? It's torque. And so the net torque is equal to, what's the analog to mass? It's moment of inertia, rotational mass. And what's the analog for rotation to linear acceleration? It's alpha, angular acceleration. And you can write down this is net torque. This is moment of inertia. And that's angular acceleration. Fnet equals ma. Next page. A couple is a set of forces, two forces, that produce a net torque, but they don't produce a net force. So the net force is 0, but the net torque is not 0. So let's take an example. I'd like you to work out this example. We've got a massless beam, so there is no mass here. And you've just got these two masses. As part of your notes, work through this example. Remember that when it asks for tangential acceleration, the equation that you need is alpha times the radius. But when it asks for centripetal acceleration, then you now need omega squared r. You need this angular speed after 4 seconds, or when the amount of time passing is 4 seconds. And then on the next page. Okay, what's Newton's second law? We just wrote it down. Go ahead and write that again. There's the second law. And now we're going to take this and substitute in for acceleration. Go ahead and try this. What is the equation, the definition of acceleration? It's a rate. What's it the rate of? It's the rate at which velocity is changing. So delta v is the numerator, not just v. Okay, well then let's multiply both, or let's just do this, actually, we're almost there. We could write that as m delta v over delta t, or we could say F net is the change in momentum over delta t. But wait, net force is simply the rate at which momentum changes. This is another way to write Newton's second law. This is another form. What we used when we wrote this down is we remembered that momentum is mass times the velocity. This is a vector. Momentum is a vector. And so change in momentum is mass times the change in momentum vector. So what's angular momentum then? Go ahead and try writing this down. The letter is L. What's mass for rotation? Oh yeah, it's I. And what's speed for rotation? Oh yeah, it's omega. the angular speed. That's the definition. Because it's the definition, we can use 3 lines for defined as, it is equal to, and defined as this. So now I'd like you to follow this follow a similar argument, and starting with the Newton's second law for torque, but for torque, derive this formula. And do that in your notes. Now, down here, how much does the angular momentum change? What is the change? Delta L equals when there is no net torque. Well, using the statement that you just proved, if this is 0, if there is no force pushing at some distance r, if there is no torque, then what's the change in momentum? That's going to be 0 too, just mathematically speaking. So if you have an object that's turning around at a constant angular speed, well, if you're not pushing on it, if there's no net torque, no forces, no net torque, then if you're not pushing, then you're not going to speed it up or slow it down, and so the angular momentum will stay the same. This will remain the same if you don't push it with a torque, and this will remain the same if you don't push it with a torque. So L will be constant. There is no change. No change in L. That means the initial value of L will be the same as the final value. And we can write this as the following. We could write the I times the initial speed, angular speed, equals the moment of inertia times the final angular speed. And we'll solve some problems using that equation.